Hello, I am Tim Komar, and I am a professional mathematics tutor and a retired mathematics professor. Today, we're going to talk about the chain rule. The chain rule is the differentiation rule for computing the derivatives of the composition of two functions. Shown here, we have the composition of a function f with a function g, which on the right-hand side here is written in this nice nested form. With this nested form, we can refer to f as the outside function and g as the inside function. We begin with a simple example, and we will compute the derivative of the composition of two linear functions. So let h here, again, be the composition of f and g, where f of x is 2x plus 4 and g of x is 3x plus 1. We will now compute the derivative of h. So we first compute the formula for the composition. So h of x is this composition of f and g. So we will substitute the formula for g inside of f over here. So we'll multiply the 2 times the 3x plus 1, and then add the 4. We get 6x plus 6. Now, since h is a linear function with slope 6, we know that h prime is going to be 6. The derivative of h is 6. Similarly, since f is a linear function of slope 2, its derivative is 2, and g is a linear function of slope 3, its derivative is 3. So we observe that h prime, the derivative of h, is the product of the derivatives of f and g. So here's what we just noticed over here. The inside function g changes at a rate of 3. When composed with the outside function f, the composition h changes at a rate 3 times as fast as the rate of change of f itself. So this example that we just discussed illustrates the basic idea behind the chain rule. The derivative of the composition of functions is a product of derivatives. Here is the statement of the chain rule. Let f and g be differentiable functions, then the derivative of the composition of f and g is the derivative of f composed with g times the derivative of g. So in words here, again, the derivative of the composition of two functions is the derivative of the outside function f here, composed with the inside function, the g here, times the derivative of the inside function, the other factor here. Our next example here, we'll compute the derivative of the function h of x, which is the sine of x squared here. So the first thing we will do is identify the outside function and inside function here. The outside function, which we will call f as we have been, sine of x, and the inside function, which we've been calling g of x, x squared. We can compute the derivative of the outside function, derivative of the sine function is the cosine function, and the derivative of x squared is 2x. Now, we can put all these pieces together with the chain rule to get the following. Our derivative of h is cosine, which again is our derivative of our outside function, composed with that x squared, our inside function, times the derivative of that inside function. And we can rewrite it in this more nicer looking way over here. And there's our first example. The next example we're going to look at is completely numerical over here. And if you want to give yourself a chance to try this yourself, you can pause the video for a moment. And I will continue. So here, we're going to let f prime of 3 be negative 2, g of 1 be 3, and g prime of 1 be 4 here. So if h is the composition of f and g, then let's compute the derivative of h at 1. So according to the chain rule, we will simply substitute 1 into the formula for the chain rule that we have been using. But now the first thing we're going to need to figure out here is g of 1. Well, we're told g of 1 is 3. So what we're left with is computing f prime of 3 times g prime of 1. And we have f prime of 3 is the negative 2. And we have the g prime of 1 is 4. So we get a negative 8 out of that. So it's just a matter of using the chain rule formula here. Here's another example. And again, if you would like to pause the video and to try this yourself first, and then see the solution afterwards, please go ahead and pause the video. And I will continue. Just like in one of our other examples over here, we identified the outside function and the inside function. The outside function here is the square root of x, and its derivative written in radical form here is 1 over 2 times the square root of x. The inside function here is that 3x squared plus 5. You see it's inside the square root over here, and its derivative is 6x. Now we have all the pieces to write down the derivative of h using the chain rule. So here, using the color coding that we've been using so far, the 1 over the 2 times the square root is our derivative of our outside part, and it's composed with our inside function here, the 3x squared plus 5. And then the first line that I've written out here gives us kind of a placeholder way of kind of thinking about one step at a time over here. Yeah, we're multiplying by the derivative of the inside function over here, which we can write it down here on the next line. And then we can simplify a little bit to get our formula. The 6 and the 2 will divide out to 3. Okay. We have one more example over here. We're now going to use the chain rule twice. And we'll get a little more of a feel of why it's called the chain rule as we do this over here. And our basic idea as we proceed here, we will work from the outermost function and proceed inward as we compute derivatives here. So here's the example. We're going to differentiate the function k of x, which is tangent squared of 5 to the x. Again, if you would like to pause the video for a moment to give this a try yourself, go right ahead. I will continue. So, first thing we're going to do, which often trips up students here, is we are going to rewrite this function in a nicer nested form over here. And we can recognize that our outermost function here is really squaring. So we can think of k here as tangent of 5 to the x, quantity squared. So our outermost function here is just x squared. And for right now, our inside function, we're just going to take to be tangent of 5 to the x. So that's our initial look at our composition over here. Well, the derivative of our x squared, again, is 2x. So we're first going to use the chain rule once here, and we're going to take the derivative of k and express it once with the chain rule over here. So it's the derivative of that x squared, the 2x, and we substitute in our function g's formula over here. And then we're going to multiply it times the derivative of that inside function here, tangent of 5x. Now, the nice thing about writing it in this way is this little placeholder notation with the prime notation says, okay, we still have something to do. And we do. We have to compute the derivative of tangent of 5 to the x now. Well, we recognize that tangent of 5 to the x is a composition in its own right. So here, we can recognize that the outside function tangent in red here, its derivative is the square of the secant function. And the derivative of 5 to the x, that exponential function, is the natural log of the base, the natural log of 5, times 5 to the x here. Now we have all the pieces to compute the derivative of g now. So here, we'll put the whole computation over here. The first line here is what we had written on the previous slide. Now, the derivative of tangent is secant squared. We're going to evaluate that at that inside function 5 to the x, times the derivative of 5 to the x, which we just commented was a natural log of 5 times 5 to the x. And then we're done. And we simply just kind of rewrite it by collecting all the nice constants out front. But there is our formula for our derivative using the chain rule twice here. So again, I'm Tim Komar. I'm a professional mathematics tutor. I tutor all high school and college mathematics courses, including your AP Calculus, your AP Stats, your AP Pre-Calculus, SAT and ACT Mathematics, anything you can think of. I'd be very happy to work with you. Please contact me if you're interested in tutoring. Have a great day.